car drives toward a skyscraper and doesn't stop. It hits the wall, locks on, and keeps going straight up. No cables, no tricks, just raw magnetism. This is the magnet crawler, a vehicle designed to defy gravity and treat vertical walls like highways. The magnet crawler started as a rescue concept, reach high-rise fires, glass cleaning robots, and urban maintenance drones. But engineers quickly realized its potential, a machine that can scale any metallic surface for military, industrial, or even exploration missions. Now it's the poster child for what happens when magnet tech meets mechanical insanity. The core technology, magnetic adhesion. At the heart of the magnet crawler is electromagnetic adhesion. Instead of tires gripping asphalt, its wheels generate magnetic fields that attract to ferrous metal walls. Each wheel houses independent electromagnets that adjust polarity hundreds of times per second, letting the vehicle crawl vertically or even upside down without slipping. To prevent power drain, engineers use rare earth magnets assisted by supercapacitors. So when the crawler pauses, it can lock magnetically without constant power. Combine that with vacuum-assisted pads for non-metallic surfaces, and the crawler can move on nearly anything: glass, steel, or even ship hulls. Balancing against gravity. Climbing a wall is easy. Staying there is the problem. The crawler's onboard AI constantly calculates weight distribution, torque, and tilt. If the body leans too far from the wall, gyroscopic stabilizers shift the chassis to stay parallel. Hydraulic arms adjust suspension angles in milliseconds, maintaining perfect alignment against gravity's pull. Think of it as a lizard, a 3,000-pound lizard made of metal, sticking to walls through physics and precision. Power and control. The power system is a hybrid, lightweight lithium supercells with regenerative braking built into the wheel magnets. When magnets release, their collapsing fields generate current, feeding energy back to the system. This loop keeps the crawler efficient and surprisingly quiet. For control, the driver doesn't use a steering wheel. It's more like piloting a drone. Cameras, LiDAR, and magnetic field sensors map every surface in real time, while AI autopilot predicts the next grip point. The driver simply chooses direction. The system handles the climb. Real-world applications, search and rescue, reach trapped victims in collapsed skyscrapers or bridges without cranes, military recon, silent vertical infiltration in urban combat zones, space exploration. Future crawlers could climb the interior of space habitats or asteroid mining rigs, maintenance, cleaning or repairing massive wind turbines, radio towers, and skyscraper windows autonomously. These machines could replace entire scaffolding systems, faster, safer, and cheaper. The challenges. The magnet crawler faces brutal physics. Magnetic fields drop off fast with distance, so even a small gap between the wheel and surface reduces grip. Temperature affects magnet strength, and ferrous metals vary in composition. A rusted beam won't stick like fresh steel. To counter this, prototypes use adaptive current control, increasing field strength when sensors detect weaker materials. But there's a trade-off: heat. Prolonged climbs can overheat coils and degrade efficiency. Cooling systems using liquid nitrogen or phase change gels are being tested to extend operation time. The dark side. Like all dual-use tech, the magnet crawler has a shadow side. A stealth model could scale enemy ships or structures undetected, carrying payloads or sensors. Terror groups could weaponize similar machines for sabotage or infiltration. That's why defense labs keep most designs classified and include strict geofencing, locks, and prototypes. Still, once something can climb a skyscraper, it won't stay secret forever. The magnet crawler isn't just a vehicle. It's proof that gravity is optional when engineering refuses to quit. From rescue missions to future warfare, it shows how magnetism can replace brute force with precision. In a world built on flat roads, this machine's next road is vertical, and the skyline is about to get crowded.